Alright, so in section 4.2 we talk about another type of exponential function, e to the x. Now you might wonder what e is. E is a special number that comes up quite often in science. E is approximately 2.71828, a little bit less than 3. Right? It goes on forever. It's an irrational number, so you can't write it in decimal form exactly. If you want to use a precise version of e, just hit second divide. Second divide will give you the e on your calculator. So when they ask you to figure out what e to the negative 3 is, you just hit second divide, and then hit your hat key, and then type a 3 in. Okay, or you can hit second ln, and then type in 3, either way. Now you can hit 2, second divide, hat, negative 0.53, enter, and then second divide, hat, 4.8, enter, and you get this number here. Now what does e to the x look like? Well, you would expect it to be somewhere between 2 to the x and 3 to the x, and it is. 2 to the x goes up slower, e to the x goes up a little bit faster, and then 3 to the x goes up even faster than that because e is between 2 and 3. And now 3 e to the 0.5x, you would expect it to go up, and you also would expect it not to cross at 0,1 but at 0,3 because a is 3 here. And it's called exponential growth there. And now e to the negative x, that's going to take e to the x and flip it on the y-axis and then drop it 2 units. And so your y-intercept that was at 0,1 is now at 0, negative 1. Okay? And your horizontal asymptote is at y equals negative 2 because it used to be at y equals 0 but it dropped 2 units because of the shifting. Example 3, you've got 3 different bizarre looking shapes here. This first one is e to the negative x squared, which is this guy right here. It's almost right on top of the x-axis. It gets infinitely close but it never crosses, and it's got a little blip here. Okay, and so its y-intercept, when you plug 0 in, you get 1, so 0, 1. It has a maximum value at this point of 1, and it has a horizontal asymptote at y equals 0. This one, when you plug in 0 for the function, you get 5 halves, this one here. And so this guy crosses at 0, 5 halves. Okay. Now its horizontal asymptote is also at 0, 0, but it has another horizontal asymptote at y equals 5, which is kind of unusual. This one here, 10x e to the negative 0.1x, this one's all over the place. This one comes all the way down here, comes up, peaks here, and then comes back down, and looks like it has an asymptote there at y equals 0. Okay, so its y-intercept, it crosses at 0, 0. Its max value, this point here, is 36.8. Its horizontal asymptote, which it actually does cross the horizontal asymptote here, but its horizontal asymptote is y equals 0. Now the most important exponential function that you'll see financially is a equals p times e raised to the rt. This is a compounding interest problem, but it's compounding continuously. Notice n is not present there. So you use all the values that we've known before, a, p, r, and t. And so 3 years is t, 1,000 is your p, 12 is your 0.12 is your r. Figure out what a is, so you multiply all this out and you get your answer there. So the function e to the x is called the natural exponential function. That's what it's called. The number e is approximately equal to 2.71828. In the formula, a equals p e to the rt for continuously compounded interest, the letters p, r, and t stand for principal, interest rate per year, and number of years. And a of t is the amount after t years. So if $100 is invested at 6%, compounded continuously, you plug all that into this formula here, and you get $112.75. Question 4, they give you a function, e raised to the negative 3x, and they ask you to figure out what each one of these values are. So you just plug in these values into your calculator. You type in e hat and use a big parentheses around your exponent there and type in these different values, and you'll get approximations for each one. Number 9, they ask you to figure out how it is shifted. Well, you start with e to the x, and then the negative in the exponent flips it on the y-axis, and then the subtract 3 drops it 3 units. So your asymptote that was at 0 is now at negative 3. Your range, it goes from -2 to infinity, and your domain is everything. Your y-intercept is -2. When you plug in 0 here, you get -2. This one, 3, subtract e to the x. You start with e to the x and reflect it about the x-axis, because a negative e to the x is flipped on the x-axis. And then you add 3. You hike it up 3 units. So your horizontal asymptote is no longer at 0, it's at 3. It goes from -infinity up to 3, and your domain is everything. Your y-intercept, when you let x equal 0, is 3 minus e to the 0, or 3 minus 1, which is 2. 3 e to the x plus 1, you'd expect it to be e to the x times 3, meaning it goes up 3 times faster, and then you hike it up 1 unit. So it's stretched times 3, and then moved up 1 unit. So your asymptote moves up 1, your range moves up 1, your domain is still the same. Your y-intercept, well, when you plug 0 in here, you get 4. With this one, you start with e to the x, and that subtract 3 inside the known function is going to move it to the right 3, and then plus 4 moves it up 4 units. So right 3 and up 4. So your y-intercept is e to the -3 plus 4. Your domain is everything. Your range is 4 to infinity. Your horizontal asymptote is y equals 4, not y equals 0. Then you got this weird one. 0.4x e to the -1.5x. Very weird. Okay, so you got a y-intercept of 0. You got a horizontal asymptote at y equals 0. And you got a maximum point of 0.67.098. Now these two ask you to figure out what f and g are for the composite function, and they give you the answer, the composite function, and they ask you to come up with what f and g are. So if you look at the original question, this one, and you look inside it for a portion of it that you can name to be g, let g equal this exponent, x minus 10 squared, and then you replace that with an x, and that becomes your f. So you pick a portion of it to be your g, label it g is, and then you replace it with an x, and that will be your f. And so this one, you can let g be the 1 plus e to the x, and when you replace that with an x, you get f is square root of x. On this one, they ask you to figure out what your minimum value is. It's a very weird function. I believe it looks like this. And it's got a low point here at 0.37, 0.69, which you can find doing using second trace 3 for minimum. Alright, 445, they give you 3 different situations that change the number of years each time, but these are all compounded continuously. They're all starting with $2,000 at 3.5%, and they ask you to figure out how much money you have after 2 years, 4 years, or 12 years. And so you plug in 2,000 e to the 0.035 times 2, figure out what that is, and then 2,000 e to that power, round it to 2 places. And the same thing with this one, same thing with that one. And as you would expect, you get more and more money each time.